So, how do we go about this? I guess we should first start by writing this IRQ. Yeah, okay, hold on. So this here is a file called IRQ. Should I not probably just create an IRQ? Yeah, that's fine. I guess that's fine. So this file would be our main module. I'm thinking, right? So public function init. So oh, hold on a minute. No, we are going to need to do this. So I guess IRQ and then IRQ.sig, something like this is needed. Right, so here we are going to define a public const IRQ, or maybe we need a public function. Because I'd like to have the architecture, quote unquote, architecture backend be a comp time constant. So yeah, maybe a public function IRQ that takes in a backend, which would be a type, and returns a type, and whoops. Right, and in here, I'm just going to return a struct in which I'm going to start by define a self, which should be this, and so so here we get the type of the backend. So I guess it means that we can just init our own backend, right? So arc is backend. I'm not sure what the rest of this will be, but we'll see as we go. So this one for now just be void. I have no idea how this will work, but we are going to see. Right. So this guy here will probably return self instead of just doing that. So return, and here with arc, I'm just going to do backend.init. I'm just going to assume that we are going to have a init function here on backend. Right. So okay. So that's for the architecture. How do we want to go about this? What would be our public interface here? So first of all, I want register. So this guy will allow. So let's actually, yeah, to design APIs. What I like to do is to actually write the usage code first, just to have a broad idea of how things should play. So usage, let's go with this. So here, what I'd like to do. So we are writing let's say we are writing a timer, simple timer, a pic or a bit timer driver. So here I'm just going to go const IRQ is, or rather, yeah, so IRQ dot register, and to this, what do I want to pass? I'd like to pass a so let's actually just create this things that are useful. So a vector, if this is fixed, right? So if we need a fixed vector, we should be able to pass 1. Otherwise, the IRQ manager should allocate one force. Right, so this is a vector, and then here we have what else should we pass? So let's imagine that we don't have just a vector, because we can, for example, have I'm not sure how to call this, but let me just call them regions. No, not regions. Let's call them domains. So we can, for example, do from IRQ for vector 0 to vector 31. This would be the system domain, right? So system fixed domain, right? And then here we can do from 32 to 64, let's say. This would be the low, or rather the yeah. So let's go low priority domain, right? And then here we can go 65, or rather this here should be 63. Whoops. So this one's 64 to 127, or yeah, 127. Let's just get this as an example. This would be the normal prio domain, and I'm just kind of coming up with this on the spot, because not sure how this would play out with other architectures that would have actual domains defined into the architecture. So this would be a high prior domain. We could have actually just went with just this, right? So this would be just the available domain, right? So we could just have this split here, but as we can, as this is an example, I'm just going to create a few more domains here to be sure. So right here, instead of just setting a vector, we should probably have some sort of object. Let's call it a vector or an IRQ config, right? And this IRQ config would be some sort of enum, and then here we are going to say something like domain is like system, and we might even go further and specify the actual vector that we want in that system domain, which would be like 2 something. Okay. So that's for that. We also need to know what is the IRQ. I want to say type. Yeah, I'm just going to say kind, I think. So this IRQ kind here would be, so what is the kind of the IRQ? So is it a fixed vector IRQ? So like these ones here, or is it an IO epic IRQ or a local epic IRQ? So maybe I shouldn't. Right, so maybe I'm just going to remove this and go with something a lot easier to understand. So let's just call this source. So IRQ source. This would be either like a fixed IRQ source. Yeah, sure. Or an like an IO epic IRQ source, or a local epic, or what else could we have? MSI. So MSI and MSI-X. Let's just go for this for now. And here, this might be a union, and for example, here in fixed, we can set some of the things that we have already put here in IRQ config. So maybe we can go ahead and do so domain would be so the system domain. Maybe just specify a vector if need be. For IO epic, so here I might actually take a look at IO epic. What do we need to specify here for our entries? So where did I define entry? There we go. So here we need to define so delivery mode, vector, polarity, trigger mode, and probably destination, and also probably destination mode, because to do implement this, because as I was talking earlier about how we want IRQs to be or to have CPU affinities, this destination mode we have set to 0, which is just a physical destination mode, whereas this destination here can actually allow us to encode a CPU affinity and just have the hardware handle that for us, handle the dispatch for us. But I'm not sure about this because as I want to balance the IRQs, I might just keep this as a physical destination mode, with the destination being just one single CPU, and have the actual kernel compute the balancing by checking on the CPU affinities for that IRQ, which CPUs are the most likely loaded, I guess, and route the IRQs to those ones. That's a problem for future me, so I don't really care about that. So this one here would be like polarity and trigger mode, and probably a domain also that would be needed. So let's actually, instead of domain, I guess we should still call them domains, because in x64 these IRQs have so 2 nibbles. So let's go for this one. This first nibble here, the top 4 bits define the priority class, and then the lower 4 bits define the I guess priority within that class. So this is x64 specific, whereas I'm not sure how the GIC in ARM handles IRQs, but I'm pretty sure that with something as broad as domains, we can have the arc-specific backend define any number of domains it wants, and we can just use those. So for, maybe just domain here, and we can let's actually do something like this. Let's try to come up with actually usable domains for x64 here, for example. So let's call this dynamic IRQs, right? And let's just get rid of all of these and probably just go here and do this. And as I've already done before, we're just going to have this domain here with just the 0xFF vector here that is for the spurious IRQs, right? So this one just catches all the spurious IRQs. So this can be okay. And domain, in this case, can be set by default to dynamic, right? dynamic. Right, so same here goes for local epic. Epic. Yeah, sure. Right, so here, same goes for local epic. We have pretty much the same thing. So a vector, a delivery mode, a what else do we have here? A destination, and yeah, so and the IPI specific stuff, right? So those are very nice. So MSI, not gonna go into details about those just yet. We're gonna see that if we ever get to PCI. Right, so that means that here we can probably just get rid of this. And here we can just do IRQ source with whatever we've seen here. Let's also go for something else. What else do we need? So maybe we need, let's go for, so we need to root this IRQ. So maybe I'm just going to go for, so hold on, I'm just going to remove this root here, and root would be, whoops, root would be an enum also, which would have something like CPU or yeah, CPU, which is just this specific CPU ID, right? Actually, let me just write that. ID is some sort of CPU ID. CPU set. I'm not sure if we can just merge the two. Yeah, for now, let's just allow them to live. So CPU set, and here we just have a bit set of CPU IDs, I guess. So this would be something like 010001 to say that, hold on, 3, 6. So let's put that as 8. And this means that core 0 and core 4 are allowed to handle this IRQ, or we are allowed to route this IRQ to either of those cores. And actually, this might be, so this is a bit set that has, ooh, this is kind of hard. This is kind of hard because CPU ID is probably a U32, but this bit set here, if we need to have 1 bit per possible CPU, it's going to be a lot. Or we can use our so options.max CPU, yeah, as the number of bits allowed here. Right, that's cool. That's cool. So here, other than CPU set and CPU, we can have any, and this one just has no nothing attached to it, no data attached to it. So this means that we can route to pretty much any CPU you want. So that's the root. What else should we have here in our IRQ register thingy? So I'm thinking maybe some name. So this would be like a const u8 or something, and maybe just default this to unnamed. Yeah, or I don't care. What else would be interesting to have here? Maybe like go back to this IRQ config stuff that we might have discussed before. But in config here, maybe we should go for masked right? So this would be a Boolean. Shared, this also can be a Boolean. This means that is it masked initially, or do we unmask it when we allocate it? Or when we register this IRQ, do we register it masked, or do we unmask it? Shared means should we allow multiple handlers to be registered to this IRQ? Oh, and of course, I guess the most important thing here that we haven't mentioned yet is the handler function. So this would be some sort of function that takes in a context and that handles this. Ooh, no, actually, hold on. Okay. So handler, this would be a struct that has a handler function, but also maybe a context that we pass to this handler function. So this would be some driver data or user data, something like this, and this would allow us to pass an opaque pointer. So this would be, I guess, yeah, any opaque to the handler function, and that should allow us to do nice things, I think. So this one be handler. Okay, I think this is starting to look pretty good. So yeah, so let's actually block this in. So register here will take a IRQ request, IRQ, or let's call it request here. And within this, I'm just going to put this just under self, a public constant IRQ request, which is a struct. Yeah, I'm just going to not care about the how should we go about this? Not going to care about the backend of the structs. I'm just going to go crazy on those, and we'll see later if we need to change those. All right, so source, this would be a source. We'll create this later on. Root, whoops, that's root. And what did I say? Config and handler. Right, so config is config and handler. Wow. Okay. Handler is handler. And of course, maybe a name, some sort of name as a const rate. Okay, so now we need to actually go ahead and create all of those structs here. So source, actually, let's just, we need 4 of those. So this one is root, this one is config, and this one is handler. Right, source, what did we say? Source, let's actually bring this up in here. Root goes up here, and config goes oops, there. Okay. And of course, let me just do this, and handler, of course, goes into handler. Okay, cool. So now let's start from here. Source is not a struct, but a union defined with an enum. Sure, so let's go for fixed, and this here would be a struct that has the main, and this would be backend dot domain. Okay, and then we have vector. This would be arc dot interrupts. Yeah, so I'm just thinking here for a bit. We know that the architecture should define. So maybe I just do dot vector ID. Maybe. Yes, of course. Sorry about that. Right, so IO. Oh, hold on a minute. This isn't right. This is not right. This should go into backend. Yeah. This should go into backend actually. So this is arc specific. For x64, we have the following, right? So IO epic, and this also is a struct that has like domain, maybe without the that. So this also goes backend domain, and then we have so this one here is nullable, I think, and it has a default of null. What's the missing integer tag type? Well, I guess I don't really care. Missing union field missing type. Oh, I see. Okay, my bad, I guess. So I guess we can put this back here, right? So let's actually get rid of this backend stuff. Right. So okay, so IOEPIC here has domain and, as I said, polarity. Not sure what that would be. So maybe let's just call it polarity, if I can just type that. Trigger mode, some other stuff. Trigger mode. Some other stuff here, if needed. And here local epic would be a struct that has, so just thinking again, so this would still have domain, right? And I guess pretty much these kinds of things. So that needs to be thought through, but yeah. So this one is just a struct that has nothing in there to do, or yeah, sure, to do if we ever get to PCI, this needs to be implemented. Okay, right, so that's it for the source. Actually, let me just pub const domain, and a domain would be a struct. So what do we need here in domain? Union maybe with an enum, and we'll have single is just a vector ID. Range is a struct structure, right? Range is a struct that has a start vector ID and an end vector ID. Yeah, and of course we need public const vector ID is, for now, let's just go for a U8. Cool. So here we need polarity, but we don't really care about that. Now, let's get to root. Root here, so we have CPU, and again, this one here needs to be a union, defined by a enum. We might want to structure the enums by actually extracting them later on, but let's move. So CPU is a struct that has, CPU is just a CPU ID, and this we can get from const arc is import arc, and hopefully this we can do just arc.cpu. Oh wait, no. Oh, no, we can do much better. We can do much better than that. There we go. So this one here can go, and we can just have this. Nice. CPU set is, of course, we need stud is import stud. Right. So stud bit set dot static bit set. I think we can size it statically. And here we can have options.max, let's just type it out, max CPU, and we need to then import options is import options, not open, but options. Right. So, and then we have any, which I guess we need to set as void. Otherwise, yeah. Okay, so let me just get rid of these. Right, now config here is fairly straightforward, I think. So we have masked boolean is equal to true. That sounds about sane. Shared is a boolean that defaults to false. Okay, now handler, we have a handler function, which should be a pointer to const function that takes in a so IRQ context. Hold on, just thinking for a bit here. Yeah, so IRQ context would be actually, we should already have a handler function defined somewhere in interrupts. So that's not it. Maybe in here, default handler. Oh, would you look at that? We already have this interrupt handler. So does it take a context? It takes a, hold on a minute. It takes in an opaque pointer, and then it takes in the actual interrupt context. So yeah, that's pretty much what we wanted to have. And this, yeah, so we pass it this context here. Do we ever get to do that though? Handler.handle, and that just goes through and does this. We pass it just the interrupt context, and it already has the self.context in there. Okay. So I guess we should just copy this, some renaming should be done on those, but actually let's get rid of this and this from now. For now. Right, so let's get that there. And that means that now we can, let me just call this handler function. And now we need this interrupt context to, so hold on a minute, I'm just going to recheck how we get that interrupt context. Okay. Right, so that's how we get that. Cool. Right, so let's go for const arc is at import arc. Still need that, I guess. Anyway, so oh, and actually, now that I think about this, do we really need this to be a type here? Couldn't we just do arc.interrupt? Whoa, how many R's are those? Interrupt backend, and just have that as the name for whatever the backend for that architecture be. I think that might be a better idea, or at least more suited to how we do things. So to do here, this can be simplified to just arc.interrupt backend instead of backend type plus generics. Right, so that's that. So now I'm just going to go here. Wait, hold on a minute. Interrupts. Do I not get interrupts? What? What is going on here? Is this not public? So maybe we should do something like this. And also, where is that? There it is. So interrupts public constant. Yeah. So we should have those there. So I guess here I should need to interrupts interrupt context. It's a bit long, but we're getting there. And actually, I don't really see why this goes first here. Just going to do this. So, all right, you know what? Just going to do it. So this one is any opaque. We're gonna decide the names when we can decide the names. So this one here has no, wait, this one stays. This is a pointer to handler, and this context here is, as I said, interrupts to ours, interrupt context dot context. Right, and that means that now I can just get rid of this and call this self dot data, right? This here goes to this goes, and maybe this one here is renamed IRQ, IRQ context, just so that we know. Right, so that's it for the handler. And I guess that's pretty much it for this part here. Yeah, so let me just remove that. And so now we need to think about the next step. So what would the next step be, actually? Well, first of all, let's simplify this thing here, because I don't really like how it looks. So I'm thinking I can get rid of this. I can get rid of these two here, and I can just get that there. So what is the problem here? Duplicate structure arc. Right, so this one here I'll just call backend, balend. And this here I'll just call interrupt backend. Yeah. And actually, const backend is interrupt backend interrupts. I'm not sure. We'll see. We'll see about that. Cool. So this now means that this goes back to being just backend, and this goes to being that. Cool. Cool. Right. So what else should we do here? Okay. First of all, when if I am a device driver, so hold on, let me just do something like this. Okay. This here needs a try, and this here needs something like this. And hold on a minute. There we go. So I'm just going to do a name in here, just in case. Root. Just going to add a few things since we are doing details. Let's do them well. This would just be defaulted to whatever the default of that is. Handler we cannot default. Source we cannot default either. So maybe to do init function in here for different functions, maybe for different use cases, we can have different functions that take parameters in a simple way to construct these things. But that's a problem for future me, so I don't care. Right, so the idea here is that I'd still want to have some control over the IRQ I'm registering, right? So I have this. What was the use case here? Let's go for timer. So I have this timer driver that would basically register this IRQ to get a timer callback on every, I guess, timer elapsed. On every timer counter going to 0. And I'd like to, for example, be able to mask and unmask this IRQ I've just registered. But also I'd like to be able to unregister it if instead of a timer I had some module that imagine something like module 1 that we can like dynamically load. And here I'm just thinking about so in the Linux kernel, for example, you could have kernel modules that you'd load in runtime, and you can also unload them. So they'd have an init function and then a fini function. And then here they basically do some cleanup, right? So if this module here is a timer driver, here we do registration for our IRQs, and here we'd like to do basically unregister and clean up the IRQs, right? So here we might need to return some sort of proxy or some sort of handle to the actual vector we've registered, right? So this would be something like so const handle is this, right? And this guy here, this handle should probably be something opaque to whoever uses it, but not too opaque. So just think about this. Right, so maybe something like a handle. I am surely going to make mistakes doing handler and handle, but how can I call this? Yeah, sure, let's just call it handle for now. No, I'll just go IRQ handle. Sure, fine, that's fine. So this guy at the end should return this IRQ handle, and IRQ handle here should be a struct. How do we go about this? So I'm not sure what goes in here. Probably going to say, I guess we can identify IRQs uniquely with their vectors. So maybe something like this. Yeah, I'm not sure, but maybe something like this would be okay. And on this guy, okay, well, on this guy, we are going to have functions, so public functions that will be available to this guy. So, and here, actually, now that I think about this, we could actually, or we are going to have this IRQ dot mask and probably unmask functions here. And we are also going to have IRQ dot root to change the routing for a given IRQ. But for now, I'm just going to riff with this IRQ handle idea here and see if that makes life easier or harder. So this guy here would have mask, right? Of course, it takes in a self, which is an IRQ handle. And do we need to pass this as a pointer? Maybe. Let's avoid copies there. Maybe we don't really need to. We don't really need to. So mask, this does nothing, I think. And then probably unmask and mask self IRQ handle. And probably release or DNet or something. Yeah, release sounds about right. IRQ handle. Right. Okay, so that so I guess he would also need release. Okay, so that's the first step. And now that we have this handle here, we can use it to do handle.mask. Should probably also get some is masked self IRQ handle, and this returns a bool. Something like this, right? So mask or not sure we need this. Yeah, these functions should just do the check if needed. Right, so that would be that. Now let's actually get to this. So register here. What it should do is first check which vector we need to work with. So 1.1 is allocate in case. Well, actually, if vector is vector specified, allocate specific vector or error. 1.2 is allocate a vector from the domain. From domain or error. So here the errors that we can have is either the vector domain mismatch, so the vector does not exist within the definition of the domain that we requested it from, or vector is not shareable, not shared, and already registered. So I guess we need to track these things. Otherwise here, allocate a vector from the domain or error. So same errors, I guess, would apply here. 2 is ask the backend to configure the IRQ. So IRQ, I'm going to IRQ source with the vector. 3 decide, or rather no, register the handler, and 4 decide if we mask the vector or the IRQ or not, or rather if we unmask it, because I'm just going to assume that all IRQs are going to start up as masked, which reminds me I should go in IO epic, and if I go down here, just going to do this. Cool. Now that assumption should hold a bit better. 5, or rather, So let's add this as opt. Maybe if we and I guess this might not be in register, so let's write this as a note. maybe if we release all, how do we go about this? If we release all handlers for a given IRQ or vector, we auto mask that vector. Yeah, so this should not happen because in theory this should not be needed because on release the I guess the IRQ should be masked, but for shared IRQs they should not be masked. Yeah, so I guess this actually holds because shared IRQs we cannot mask them on release, so we need to wait for all handlers to release before we mask that. Okay, fine. So I guess we need to go through the motions for this one here. Right, so one is we need a vector. So how do we get about that? So we have source. We have either fixed. I guess all of these need to have this vector here, and now that I think about this, would this not be easier if, let's write this here. So const source to source returns. And then I'm just going to go like this. And then I'm going to go kind is a union enum and fixed, whoops, and let me get these like so, get rid of this, get rid of this, and that looks quite a bit better to me. Right, so go here, delete that. Okay, so that works. That actually does work, I think. Right, so if so thinking, so const vector is if IRQ request dot source dot vector as vec, right? I guess here we have an else, which is the case for when it's not there. Right. Actually, hold on a minute. There we go. So here we need a vector allocator. So I guess this guy here needs a vector allocator of type vector allocator, and vector allocator is, of course, this. I forgot to change this. Vector allocator dot init So all right, let me just write this as a comment here. Might need to know about the domains. Will need to know about the domains. Domains definition should be a comp time as far as the assumptions we're making are go. Domains should be comp time constants defined by arc-specific code, right? So let's move. So this means that now we can go ahead to do self dot. Ooh, hold on, we are missing a bit of a self here. Right, so vector allocator dot alloc. So here we know that we have a vector, so alloc specific or alloc specific vector, and here we need to pass it IRQ request dot source dot domain and vec. Right, so this guy here needs to, this would need to be made a lot easier in Zig, because it's quite verbose for now. So this one here, we need to break block with this value here, right? Okay, fine. Otherwise, let me just get this guy here, and here we can just alloc from the given domain. Actually, I'm just thinking about this, but we should probably have, so let me think. We should probably make this be a nullable also. So domain being optional means that we define in vector allocator or in backend, so somewhere and the default domain. So we have this notion of default domain, and if we have no domain, we allocate from the default domain, which sounds pretty okay to me. Right, so here we go. Next is self.backend.configure source. And here we might want to pass it IRQ request dot source dot kind, IRQ request dot config, IRQ request dot handler. No handler yet. So I guess that's pretty much all we need to pass it. Root, maybe? Yeah, we need to pass it root, and we need to also pass it the vector we've just got from this. Right, and then here we need to do self dot. I guess we need some sort of handler chain. Yeah, so this needs to be self dot something. Let's just call it handlers dot this needs to be tried, probably. This also needs to be tried, probably. So handlers dot, how am I going to go about this? So wait, hold on a minute. What do we have in config? We just have masked. Right. So dot register IRQ request dot handler and IRQ request dot so hold on a minute. Dot config, I guess, or dot config dot shared. Yeah. that sounds about right. So hold on, let's just rewind this a bit and think about the state of this after each of the executions here. So here we check that the vector is allowed, and then we can allocate it. So no, this is not enough. Definitely not enough. We need to also give it we need to also give it so shared is IRQ request dot config dot shared. So this needs to know if the IRQ is shared or not, if the vector is shared or not, because if the vector is not shared, no, hold on. If we want to register a shared vector, but the vector is already registered and it's shared, then it's all good. So we can reallocate the same vector and reuse it. If we want to register a, I guess, exclusive vector, and so hold on, did I have this anywhere here? Yeah, so if we wanted to register an exclusive vector and it's already marked as shared, then that's an error. And the other situation is also an error. So if it's already marked as exclusive and we want to mark it as shared, and if it's already exclusive and we want to mark it as exclusive, that's also an error. So yeah, I think here we need to send IRQ request.config.shared to both of these. Make sure that it actually does work correctly. Right, so here we get a vector only if and only if we either can share it or we have the exclusive use of that vector, right? Right. So here we have a vector, and all we want to know is, or all we want to do is have the backend configure the source to get whichever vector or whichever IQ we are talking about to that specific vector that we want. So basically just link in the IRQ to the vector, and that can be a number of things. So in case of IO epic, that would just be a redirection table or something. In case of a generic device driver, that would just be a generic, I guess, IRQ source that we give it, and it gets that configured to its source. So for example, MSI, or things like that. Yeah, so, but we don't have details for this, but we are going to move here to register the handler. So we just need to know, we also need to know the vector to which we need to register that handler. So handler, is it shared or not? Because I guess, I guess this, yeah, I guess we need that because this shared config here for the handler should also be matching the nature of the vector. So they should either both be shared or both be exclusive. So we need to pass that to both of those. And then here, if so if IRQ request.config.masked So I guess configure source, we can remove the config from here. Yeah. So I guess we can do something like this, and then here we can do something like try self dot unmask and a vector. Right, that sounds about how we would expect it. Right, so now we have this, we need public functions mask takes in a self and returns a probably an error void, and then here we need to do self.backend.mask. Whoops, this also needs a vector, which is a vector ID, and this goes like this. So same goes for unmask. So unmask here, and whoops, not what I wanted to do, but okay, unmask here, and public function unregister, or let's normalize this to release. So self and I guess we can just take a vector ID. No, no. We need more than just a vector, because, for example, if we want to unregister the handlers, we need to unregister the actual handler for that specific IRQ request that we've registered. So yeah, that might be a bummer. So here we need to also, so how do we go about this? We need some sort of ID and or a pointer of some sort to the actual handler. So handler I'm not sure what we need to put in here, so I'm just going to, for now, put in AU64. We are going to need to work around those. And actually, this brings me to this. So note, what should happen if we have a shared vector with multiple handlers? Should we mask it for all of them, like a hardware mask, or maybe do a software mask if no, this is too complex. This is getting out of hand. I just might only support unshared vectors. That would make life a lot easier. So but no, for now, let's just keep it the way it is. And I'm just going to note here, mask always does a hardware mask. So all handlers will be, will not, so IRQ will be masked for all handlers, right? So I'm just going to copy this and mask for all handlers. So beware in case some of them are not ready to actually start receiving the notifications. So yeah, so this guy here just errors or void. And as I said, we also need to know the handler. So hold on a minute. Does this not mean that this guy needs to also return some sort of handler, like handler proxy or something? And we do the same sort of so this guy would be a handler proxy or something. Yeah, you know what? We can just go about this like so, and this, of course, we forgot to do it here, but we need a vector to be vector, and we want handler to be handler ID, ideally. Right, so this release here would be yeah, U64, fine. And so we need to do the operations in reverse. So first of all, we need to so hold on a minute, just thinking about this. Do we need to mask the IRQ while we handle the handlers? I'm not so sure. That would be ideal. We need to actually disable IRQs or just mask this specific vector just in case. But for now, I'm not going to try that just yet. But first of all, try self.handlers dot release well, handler, right? And then next would be try self.backend dot how do we go about this? Release source for vector, and then try, what's the last step? I guess it's the freeing of the vector itself. So self.vector allocator dot free vector. So I guess that's about it for at least for this first part. Let's bring the domains up to here. And yeah, so now this gives a broad idea of the things we need to work on next. So this is done. Well, actually, it's yeah, it's work in progress, but it's the idea is there. So this guy here is also done. We haven't handled priority though, but I guess that's what the domains are for. Because for x64, domains, or rather the vectors, the IDs of the vectors encode priority. And in other architectures, we can just, I guess, segment the vectors to have different priorities. And yeah, so that should be also good. So the handler function is also done. This is okay. Yeah, that should be fine. Yeah, we probably need to do this kind of tracking here. But we still haven't done that, and we don't have anything to do with the stats. So yeah, that's pretty good progress. We need a vector allocator. We need to register the allocations, and we need stats. So I guess those are the topics we are going to handle next. Well, that's pretty much it for this one. We have started work on IRQ handling, or advanced parts of that. Not sure the current design is the optimal design, but we are going to explore it and see where it flinches. Stay tuned for more of this. I'll see you next time. Fucking out.